Okay, we'll get started now. So we'll start. The way I've structured this session is initially we'll look at some of the basic stuff regarding functions and so on, and then we'll do some questions. What I'm going to focus this session on is stuff which is basic, which a lot of you think you know, but still you are not very good at it, and that results in you're making mistakes in the exam, or you're not being able to solve the questions within the scheduled time. So we'll quickly go to this session. We have a lot of material to cover depending on the interest and the number of people, and how we are going through this session. I'll decide if I want to cover all of it or I'll stop at a certain level. So we'll start our session right now. So functions you can assume just like a black box. So anything which comes in, the function transforms it to whatever it needs to do. For example, if a function is fx equal to x square, what this function does is whatever is the input, it will square and give you the output. So if the input is x, the output is x square. If the input is y, the output is y square. If the input is x plus 3, the function will just square it and give you the output. So that's all a function is. It's just sort of an operator which takes an input and provides an output. If the input were a plus b, the output would have been a plus b square. And then the function can be of different sorts. So this is an f square function. The function can be fx is equal to x plus 3. In which case, just a second. I'm getting a message that you can't hear you. So is that a problem with many other people? Okay, it seems some people are able to hear. So Rohit, it might be a problem at your end. If a lot of you cannot hear, just raise that again, and then I'll check if there is a problem on my side. So we'll continue with this session. Rohit, you can sort that out, and later on you can watch the video if you missed something in the beginning. So similarly, if the function is fx equal to x plus 3, whatever the input it gets, it will just add 3 and provide you with an output. So if you provide x, function x will just add 3. If you provide a plus b to the input, this function will just add 3 to whatever the input. So that's how you should see a function, as a black box, as an operator which does whatever comes into it. So this is a basic introduction to function. Now we'll see a few more stuff on which questions are created. So and a lot of you know this, I know a lot of you know this, but still it's worth having another look. So FOGX, which can also be written as FGX. So this is just a way of writing, so nothing to get confused about. What this is saying is that on X we'll first apply the operator G, and then we'll apply the operator F. That's all it means. There is nothing very complicated about it. And we'll just look at an example to see how it works. So there is one function which adds 3 to whatever it gets as an input. If it gets x as an input, it produces x plus 3. There is another function which squares whatever is the input. So if it gets x, it squares it to x square. If it gets y, it creates y square. If we had to calculate FOGX, which is applying g and then f function, what we'll do is first we'll apply g operator. So x is the input. When the operator is applied, it becomes x square. And then we apply the f operator. And f operator, what does the f operator do? It does just adds 3 to whatever is input. So when it gets x square as input, it will do x square plus 3. If we had to calculate g of fx, then we'll first apply the f operator, first function. And the first function adds 3. So fx will be x plus 3. And then we'll need to apply that to g. So g will just square whatever it gets as an input. It gets x plus 3 as an input. It will square that. And here you can also see that FOG is not necessarily equal to g of f. Some cases it might be, some cases it might not be. Applying the same function twice, FOF, some people, students get confused, you do not need to. FOF is just applying the same function twice, and that will work this way. So first you apply fx once and you add 3 to the input, because that's what the function does. So you get x plus 3, and that output goes into the new input, which is again the same function. So this will again add 3 to whatever has been input. So it becomes x plus 3 or x plus 6. ggx is again the same thing. First time you apply g function, it becomes x square. Then you apply it again and it becomes x to the power 4. So just a second. So this is, I was just accepting some of the friend requests which have come in. So this is how you apply FOG. Let's look at a question. The question is not a straightforward, it's a difficult question, has come in CAT earlier, but once you have done it a few times, you should not be not solving this question. अगर ऐसा question आता है तो आपको खुश होना चाहिए, because if you have practiced well, it should jump out to you how to solve this. So let's see what the question is. Fx has been provided, so you know that the function is x minus 1 by x plus 1, and then you have been said that y1 is fx, which basically y1 is fx. Then they say y2 is ffx. So basically the number of times you apply the same function on the operator, that's the coefficient of y. So y3 will be applying f 3 times, and so on. What you have been asked to calculate is y501. Now I think the question, whoever made the question made it easy by giving 501 as coefficient. If they had given 9 or 13, then it would have become much more difficult, because if it would have been 9 or 13, then you had two options. Do I calculate 9 times? Do I calculate 13 times? Or is there some other method? If it is 501, you know that it's not possible to calculate 500 times. There has to be another method. And what generally happens in such questions is that after you calculate 2 times or 3 times or 4 times, you will see the expressions start repeating themselves, and then you don't need to calculate any further. Let's see what I mean. So y1 is fx. We know that, x minus 1 by x plus 1. What would y2 be? So y2 would be f of x minus 1 by x plus 1, because we have to apply it twice. The first time you apply it, you get this as an input. Now you need to apply this again. What does the function do? It takes the input and then subtracts 1 and adds 1 and puts it in a numerator and denominator. So we'll do the same thing here. So we again do the same thing, x minus 1 by x plus 1 minus 1 by x minus 1 by x plus 1 plus 1. Now, your speed improves by doing these things quickly. It does not improve by knowing Vedic maths or knowing what 1 by 33 is equal to. All that is useless. You spend some time, it hardly saves you like 10 seconds during 1 hour. But what saves you speed is, one, knowing how to approach the question very quickly, and then doing these kind of calculations quickly. You should not be like writing all the steps. You should be doing it quickly in your mind and still ensuring कि गलती ना हो. मतलब एक message आना चाहिए कि I don't need to make a mistake here. So here if you do it, you'll get minus x minus 2 and plus x plus 1. So minus 2 by 2x are equal to minus 1 by x. So this is what you'll get. Now you do not need to sorry guys for the disruption. So you do not need to think about this part. So this part should be fairly quickly. Sorry, I got distracted a bit. So this part should be done fairly quickly. You look at the expression, you should know the answer, what it is. And then I need to apply it again. So I apply it on f minus 1 by x. And I get minus 1 by x minus 1 by minus 1 by x plus 1. And this again, I can solve fairly quickly. This will be minus 1 minus x by minus 1 plus x, which is equal to x plus 1 by 1 minus x. Still, I do not see any repetition. I do not know whether it will be solved. And at this point, doubt might start creeping in. But if you calculate it once more, so now I'll calculate y4, which is again taking the output of the previous one and applying the same function. you will notice that you'll have to do it, but I have done it before, so I know that this answer will come out to be x. So if you apply the same function 4 times, you come back to where you started from, which is x. So you started with x, you applied the same function 4 times, and you have come back to x. Using that, you can solve the question now, because you need to go till y 501. But you know that y4x will be x, and then again y8x will be x. So if we write it as f500x, this part is going to be x, because after 4 times it will keep coming back to x. So you need to the answer will be fx, which is equal to x minus 1 by x plus 1. So जब पेपर मुश्किल आता है तो it's not like they increase the difficulty of the question a lot. They'll just introduce questions where you need to work a bit more, as in do a bit more calculations, go through a bit more steps. Those kind of things they'll increase. So वो थोड़ा सा ध्यान रखना होता है. Sometimes the paper might be difficult and you might have to like try till 5 also. Here also 4 is not you have to try till 4 y4, which is not very straightforward. But this is a question which I would think people should solve in the exam. If you are preparing for 8-9 months, then such questions are the ones which will differentiate between people who have come well prepared and people who have not come in well prepared. बहुत आसान होगा तब तो सब लोग ही कर देंगे. बहुत मुश्किल होगा, then none of you will be able to do it. Very few people will do. So these are the ones which matter. So एक बार try revising it, write it down and revise it, because आपके हाथ भी तेज चलने चाहिए. Like if you read it, you won't know what all calculations are needed and how you could do them faster. Because in the exam you need to do this in like 90 seconds or something. So this is what, but write and revise, I would suggest that. If you are not very comfortable with such questions, if you are very comfortable, then no point, you can move on to tougher things. Let's look at another question. So this is a type of question actually. There will be a lot of questions you'll notice in function, and these are not easy questions because you do not know how exactly to progress in this front. So you'll see stuff like fx plus y is equal to fxy, or they might give you something else, fx plus y is equal to fx plus fy, or fx by fy, or any other relation of this sort. So the problem is you do not know how exactly to progress, and it will be a challenge. These are again previous year's questions. It's not like I have created them. So, but what you should try always is try and substitute some values in these functions, because that will give you away. The kind of value that you want to substitute is to get the number inside the function as 1 or 0 or something like that, because then you will get some flavor of the function. For example, in this question, fx plus y is fxy, and then we have been given f minus 7 is 7, and we need to find the value of f minus 49 plus f49. So what can we do? First we try, so you can try various substitutions. What we do is, let's say y is equal to 1 and x is equal to 0, because this function has to be true for all values. So if you choose y equal to 1 and x equal to 0, it should be true. So then it comes as to f1 is equal to f0, because you will put x is equal to 0, y equal to 1, and this side will be 0. So f1 is equal to 1. Same way, if you just put y equal to 1 and x, leave x, it becomes fx plus 1 equal to fx. Now this, once you are a bit comfortable with functions, this should strike you as a bit odd. So fx is equal to fx plus 1, which means for any value of x, fx and fx plus 1 will be the same. So f1 will be equal to f2, because x is equal to 1 and fx is equal to x plus 1. f2 will be equal to f3. f3 will be equal to f4. So this indicates that the value will be the same for all values of the function. So that way we can say that if f minus 7 is equal to 7, then f minus 49 will also be equal to 7, and f plus 49 will also be equal to 7, and hence the sum will be equal to 14. So very straightforward question. If you go in the right direction, if you have practiced well enough, it should not take you more than 45 seconds in the exam. If you haven't, it might take a lot more time. So again, sometimes you might go in the wrong direction, start substituting a few wrong values, but still it should not take you more than 2 minutes or 3 minutes to solve, and you should get these marks when you're working. We'll do a similar one again. or I can leave that for you guys to practice. So here again, it's a similar set. What has been given is fx plus y is equal to fx into fy. And then we need to find the value of f. We have been given f4 is equal to 3, and we need to find the value of f minus 8. You will, when you start substituting values, and some of them will not lead to anything, but I know which ones will lead to something. You put y is equal to minus x, and you will get f0 is equal to fx f minus x, right? And if you put both values equal to, so if we put x equal to 1 and y equal to 0, as we had earlier, then you will get f1 equal to f1 f0, or f0 equal to 1. So from this, when you substitute it over there, you will get fx equal to 1 by f minus x. So we know that using this, we know that f8 will be equal to 1 by f minus 8. And to calculate the value of f8, you can just substitute x equal to y equal to 4 in the initial relation. So f4 plus 4 is equal to f4 equal to f4 square. And f4 is 3, so this is 9. So f8 is equal to 9. F minus 8 is equal to 1 by f8. What I would recommend is, even if you're not following the solution, don't worry about it. See the previous question solution, try and imbibe the message in there, and then try and solve this one on your own. That will help your brain development and help your understanding on the functions front as well. So, so these are the questions I have in functions. Now we'll start looking into some of the algebraic functions, expressions, and their graphs, etc. But I'll just pause for 2-3 minutes here and just see if you have, in case, any questions, if it is engaging, if it is boring, and so on and so forth. Because if it is not very engaging, then we can try and find different methods to go about this stuff. So it's right now 2:28 by my clock. I'll wait till say 2:30, and then we'll begin again. Read about to go about all the functions, graphs, and their transformations. So I'm not getting any comments back, so I'm just okay, I got something, but just in case, if you are following or hearing, just some feedback would be good, because it's a bit difficult to know whether people are even listening or am I talking in vacuum. So I had taken a pause for 2-3 minutes, and then I'll begin. Hi Vishnu. So now what we'll do is we'll start looking at types of functions, and there are these algebraic functions and their graphs as well, because graphs are important. So first there will be these algebraic functions, and you have like y equal to x, whose graph is a straight line. You should know all these graphs by heart. You should not be thinking about it. You should just know. Uh, Vishnu is asking, could you go a bit slow? I don't want to, Vishnu. I want to go fast. If you find it difficult, you can watch the videos again. The reason for that is that I also wanted to give you a flavor on how you are expected to act during the exam. During the exam, you won't have the time to go slow. Yes, right now I can go slow, but eventually you'll have to bring up your speed. Uh, so I will vary my pace accordingly, depending on which part we are in. If it's a very easy to understand topic, I will go faster. If it's a slightly tougher question, I'll go slow. But having the video helps that you can always go back and revise later on if you don't understand something. So y equal to x, we know this. Y equal to x to the power x square, x to the power 4. The graph will be of this form. It keeps getting steeper as you increase the coefficient of n, coefficient of x. So this might be x to the power 6, x to the power 4, x to the power square. If the power is odd, then the graph becomes of this sort. So this is x cube, and then again you can, this will be x5 and so on. So these are graphs which you should know by heart. Same way, you should also know that for a polynomial function, the only thing you need to know is that the graph will be continuous and smooth. That much you should know. The shape you cannot comment on, but you always know that this graph will be a continuous smooth graph. It won't have breaks in between. And the number of times it crosses the x-axis is the number of solutions it will have. So if you are given that a equation has only one solution, then it means that its graph will cross this line only once. If it has 3 solutions, it will cross it thrice. So this you should know about that graph. 1 by x to the power n, where n is equal to odd, the graph will be of this form. And 1 by x to the power n, where n is equal to even, the graph will be of this form. Sorry, my bad. The graph will be of this form. So all these graphs you should know. So these are polynomial functions. Then there are trigonometric functions, and these graphs also most of you know anyway. Sin x will be the function, whatever is the input, it will provide the sign of that function as that number as the output. It reaches a maxima of 1 at pi by 2, and then reaches 0 at 180 degrees C, and same way it will take this one. Cos x will be of this form. And all these graphs you should know very well, as in like the back of your hand. If I ask you to draw all the function graphs that you know, you should be able to draw them within 1 minute or 90 seconds. This is 0, this is 1, sorry, at 0, and then at pi by 2 it will reach 0. And then tan x will be of this sort. So tan x will have a break here, and then it will have. So all these shapes you should know. 0, and then it reaches infinity at pi by 2 and minus infinity at minus pi by 2. So these are trigonometric functions. Same way, exponential and logarithmic functions. Exponential, the graph will be of this sort. It will cross the axis at 1 and then keep increasing. Log function, the graph, and then again it will be 1 here. This is for a greater than 0. So base has to be greater than 0. Here also e is greater than 0. So some people ask why we need to know these graphs and how do they help. One, there have been questions which have been asked directly on the graph, but even if you do not have a question directly on the graph, knowing that helps you solve all other kinds of questions. For example, just knowing this, you know that e to the power x will not be negative, or log ax cannot take values for negative values of x because it's not defined in this area. And there is a lot of similar stuff you can do, and we'll see a few questions very shortly. So absolute value, again, most of you know the basic stuff, but we'll just revise it once. Mod x is defined as a function. So the function mod x is a function which just gives you the absolute value that is in there. So if 2 gets input, it will provide 2 as the output. If 0 is input, it provides 0 as the output. If -3 is the input, it will provide 3 as the output. So it negates the negative sign and just provides the output. And that's why you can write the function this way also, which helps a lot in solving equations and so on. Because if x is greater than 0, then it just returns the number. So it will be equal to x. If x is greater than 0, it will just return x. If x is less than 0, however, it will return minus x, because it will just change the sign of that value. The graph is of this sort because it is y equal to x on this side and y equal to minus x on this side. So it's just those two lines for x greater than 0, which is this part of the curve, and x less than 0, which is this part of the curve. So this is a modulus function. Now all these graphs, as I can't repeat enough, you should know very well, you should understand them very well, just like they should be like your friends, if I can make that analogy. Graph transformation. I'll go through this quickly. Some of you might feel that it's going too fast, which is fine. You need to write and revise later on. If I go slowly, you don't need to do all the learning right now. Right now, you need to know what you need to learn, and then you need to revise it through, write these graphs down, draw them, and that's how you'll become better at this stuff. So, first, graph transformation. Graph transformation is basically how we create a different graph from what we have. So if you change the function in the function, if you change x to minus x, then you just need to invert the graph around y-axis. Whatever was on the right hand side of y-axis, create it on the left hand side. Whatever was on the left hand side, create it on the right hand side. For example, if you y equal to e to the power x, we saw the graph just now. If we replace x by minus x, as we have done here, x by minus x, the graph will change to this. Oh, sorry. The graph will change to this. So it just got reflected. Same way, if this is y equal to 2x plus 3, you can just, if you replace x by minus x, then it becomes 3 minus 2x. And then whatever was to the right of y-axis will come to the left, and whatever was left will go to the right. So this will become the graph of y equal to 3 minus 2. Same way, y equal to x square, you replace x with minus x, the function remains the same. That is because it's an even function. I didn't cover it right now, but you might be knowing for an even function, f minus x is equal to fx, and x square is an even function. In this case, you can change the right to the left and left to the right, but since both are same, the graph will remain the same. And this also brings up the point that for even functions, they are symmetrical around y-axis. Just by looking at the graph, if you have to identify whether the function is even, it will be symmetrical around this axis. If it's a mirror, there will be a mirror image on both sides. So this is how you can transform from x to minus x. If we put x plus something or x minus something, then the graph just moves. So if you replace x by x plus a in a function, the graph will move a units to the left. And if you replace x by x minus a, it will move a units to the right. For example, y equal to x square, you change it to y equal to x plus 2 square. What we have done is we have replaced x by x plus 2. And when you do that, the graph has to move 2 units to the left. So now the new graph will be something like this. Same way, if you have log x and then you change x to x minus 2 to get the graph of log x minus 2, then the graph will move 2 units to the right. So earlier if it was crossing at 1, now it will cross at 3. Y equal to mod x graph is known to us. We need to plot y equal to mod x minus 2. We are just replacing x by x minus 2. Again, move it 2 units to the right. And this is the graph of y equal to mod x minus 2. So this way you can create different graphs as well. Similar transformation on y, you will move around the y-axis. If you replace y by y plus a, move a units down. If you replace y by y minus a, move a units up. E to the power x is given. You have to plot y equal to e to the power x minus 3. So basically you are changing y by y plus 3. You move 3 units down. So if it was crossing at 1, Now it will cross it, -2. And same way, if we need to plot y equal to sine x plus 2, it is the same as a substitution of y by y minus 2, which moves 2 units up. So this will be, oh, sorry, I was substituting a previous, 2 units up. So the sine function will move 2 units up. It will be something like this. Well, cross at 2, maximum will be 3 and minimum will be 1. So just from the graph also, you know that this function will never be negative. Its lowest value will be at 1, its maximum value will be at 3. There are other ways also, but the graph helps in envisioning these kind of things. This might be getting a bit of an overload, but still I would request that you go through it, you stick through it, and then go back and revise at home, and then you'll become much more comfortable, much more conversant. The idea should be that you should be able to take this lecture. If you are an expert, you should be able to sit and teach this stuff, that if you take x by mod x, this is what will happen and that is what will happen. And for that, you will need to write and practice and get very, very comfortable with it. So again, if I replace x by mod x, I just need to reflect whatever is on the right hand side on the left hand side. Whatever is there on the left hand side we ignore, and we take whatever is on the right hand side and reflect it on the left hand side. For example, if log ax is the graph as we had seen before, when we put x as mod x, this is the graph. So it gets defined for negative values of x also, because mod x will always be greater than 0, and you get this kind of a graph. And from graph you can say that, okay, whatever observations you want to make, that now it is defined for all x's, negative and positive, maxima will be same, minima will be the same, and so on. Y equal to x minus 3 square, this is the graph, and we'll see how we come here. But if then somebody wants to ask you to plot y equal to mod x minus 3 square, you can just take whatever is on the right hand side, which is something like this, and then plot it on the left hand side. So this is your y equal to mod x minus 3 square. And we have one more, which is if we take the mod of the entire function, then you just flip what is below the axis above the axis. So it's a bit different. So what you do is just take whatever is below the axis and flip it above. So from this point onwards, you flip this part above. So if y equal to 1 minus x was this, y equal to mod 1 minus x will be of this form. We have just taken what was below and we have flipped it above. Same way, if y equal to log ax is like this, y equal to mod log ax will be like this. With this, I have discussed all the transformation. You should be able to draw this graph now on your own. I will pause for 2-3 minutes. If you want to take a shot at this, take a shot at this. I'll catch my breath, have a drink of water, and I'll see how many people still stick around, because we have a lot of things still to cover. So please try creating this graph, and if you're not, we'll do it just after this 3-4 minute break. So I'm not getting any responses except for Harish's yes. So I'm a bit concerned now whether people are still listening or have just left the lecture open and have wandered away. And maybe I went too fast in the previous section. But let's see how we'll do this chart. And feel free to comment if you want to cover the remaining stuff later on or some other time. So we know how to draw y equal to x square. Then we can make the transformation x to x minus 3, and you'll get the graph of y equal to x minus 3 square. And then you can make the transformation of x to mod x, and you will get y equal to mod x minus 3 square. So this is how you'll get this graph. So let's draw this. This will be y equal to x square. X by x minus 3, if you have done it enough number of times, you know that this will just be moved 3 units to the left. So this is x minus 3 square. And then you just need to replace x by mod x. So x by mod x, what you will remember the transformation later once you practice it. But what it is that you ignore whatever is on the left hand side and just replicate what is on the right hand side. So on the right hand side part, we'll just replicate it. So this will be the graph of y mod x minus 3 square. And so the way graphs are useful is just by looking at it. Now you know question. Sometimes the question will be directly on graph, but many times the question can have implications which can be drawn very easily from the graph. If the question asked, say, for what values of x will y equal to mod x minus 3 square have, for what value of y will it have 4 values of x? So what is the value of y for which 4 values of x can satisfy it? So you can see that it's these values. Here there are 4 values of x, right? So you can very easily say that for these values of y, there will be 4 values of x. For other values of y, there will only be 2 values of x. So such questions can be very easily answered using graphs. So you know this value is what? For x is equal to 0, so this is 9. So 0 to 9 value of y, there will be 4 values of x. And for y greater than 9, there will only be 2 values of x. So the question may not mention anything about the graph, but knowing the graph will help you answer questions. These are some I have left for you to do. Try them. If you're not able to draw them, I request that you just draw them and post it in the group or somewhere so that we can check and verify and know that you have drawn the right thing. But at least try drawing these by yourself just for some practice, whether you have understood the transformations well enough. In graphs, just the shape matters a lot. The values do not matter that much. Values you can always find out once you have drawn the shape, but should just draw the correct shapes for all these. This question we have discussed on our group as well before, so some of you might know, but it's a good question, so I've included it here as well. So what the question asks is that how many points do the graph y equal to 1 by x and y equal to x square minus 4 intersect each other? So if we draw it separately, y equal to 1 by x will be this kind of a graph, y equal to x square minus 4 will be, x square is this, and then we are replacing y by y plus 4, so basically 4 units down on the y-axis. So x square minus 4 will be this kind of a graph, right? And this is y equal to 1 by x. How many points do they intersect? So we'll need to draw them on the same if we draw them. So the doubt here is, it's very clear that there will be 1 point of intersection in the first quadrant. So I have drawing y equal to 1 by x. And it's very clear that it will intersect at this point. But it's not very clear whether it will intersect in the third quadrant. And if you look at the solution in the book, they'll say it's obvious that this is how it will be and there will be 3 points. This is actually the right thing, but it doesn't, it's not very clear why it can't be this. And for that, you should ideally check whether it will move above or whether it will intersect twice in this quadrant. And when you check, how will you check? You know this value. This value is y equal to 0, so this value will be minus 2. You can substitute and check. So around 1 is a good number to check whether if 1 by x is higher than x square minus 4, then it will intersect it twice. If it were not intersecting, if the situation were like this, that 1 by x is like this and x square minus 4 is like this, then for no value would 1 by x be higher than x square minus 4 in the third quadrant. So you check for minus 1. For minus 1, 1 by x will be equal to minus 1, and x square minus 4 will be equal to minus 3. So for minus 1, this value will be minus 1 and this will be minus 3. So it has to be this case where they intersect thrice. So this requires a fine understanding of graphs. I do not think it's very easy to do it just by equating and solving equations. Think about how you would have gone about this. Try and figure out why I did what I did over there, and then you'll start seeing the beauty of the question. This one again we have discussed on the group, but I'll do it because a certain number of questions have been asked of this format, and you can always get more questions like that. So we'll do this just to ensure that you guys do not flip and you guys are fast enough. You should not be very slow in doing such questions. But even the previous one or this one, I am plotting all the steps and doing all of it. But if I had to do it myself, I won't plot everything. I'd very quickly draw the graph and go about it. So you should reach that level of expertise. So let's see. What the question asks is, a function is defined as minimum of two functions. So one function is minus x minus 1 square plus 2 and x minus 2 square plus 1. And we want to find the maximum value that this function can take. So let's draw the two graphs. This is minus x minus 1 square plus 2. So you know the graph of minus x square. Then you can make the substitution of x to x minus 1. And you'll get y equal to minus x minus 1 square. And then you can make the substitution of y to y minus 2. And you'll get y equal to minus x minus 1 square plus 2. So let's draw the graph. This will be minus x square will be like this. Then x by x minus 1, which means 1 unit to the right. So this becomes this. And then y by y minus 2, meaning 2 units to the top. So it becomes like this. The graph will be something of this sort. And same way on this side, x minus 2 square plus 1. You start with y equal to x square. Then make the substitution of x to x minus 2. And you get y equal to x minus 2 square. And then substitute y by y minus 1. And you get x minus 2 square plus 1. Let's draw the graph. X square, x by x minus 2, and 2 units to the left. And then y by y minus 1, which means 1 unit to the top. So it becomes something like this. So, sorry, 1, 2. So, Ram, if you want to know this question, the question that I am solving right now, no, I think it would be very tricky. It can be done, but it would be very tricky to do it that way. You should do it using graphs. You should not feel very scared using graphs. This is the easiest and best method to avoid calculation mistakes, etc. So these will be the two graphs. And when you draw them on the same, and then the function says that we need to, the function is actually the minimum. So fx is minimum of minus x minus 1 square plus 2 and x minus 2 square plus 1. So how do we choose the minimum? You just shade the part which is lower, because for that value of x, that is the function which is lower. So if I had to take this function, this will be the function definition. This is actually the function. And then you have to find the maximum value this function can take. And those values would be either this or this, because here the function is increasing. So it increases, it reaches the maximum here. And then it again starts decreasing or changing, and then again it reaches the maximum over here. So either of these two values would be the maximum, and that you can calculate it up. Ram, I'll come to your question. I know what the books suggest, and it's not the right way to go about it. So then you need to solve for the x values and then take whichever value the y is maximum. And that also would not be very, it should not take a lot of time if you are fast enough. Just pull this to this side. I'll try and do it in one step itself. So it will be 2x square 4 and 1 5 minus 3 plus 2, sorry, 5 plus 1 6 minus 2 4 and minus 4x minus 2x minus 6x. So I think I've got it right. So this will be x square minus 3x plus 2 equal to 0, or x minus 3x minus 2x minus 1. So x is equal to 1 and x is equal to 2 will be the two solutions. For both you need to calculate y by substituting. So you can substitute in either one and you'll get y equal to 1 or y equal to 5. So y equal to 5 should be the answer in this case. So again, it requires a bit of work. It doesn't require as much work as I have shown here, because you have, once you become comfortable with graphs, drawing those two graphs is not a very tough ask. You can draw that fairly quickly. I have here shown it to you, and that's why it has taken so much of time. And then you just know by equating. And now the question can be asked, various questions can be asked of similar type. And and there are various questions out there. That's why a lot of you have seen them before also. So you can, like, I'll just make up something over here. The function could have been defined as max of, say, mod x and 4 minus x square. And then you could be asked to find the minimum value of this function. Again, you can do the similar stuff. These are slightly easier to draw. Mod x, you know the graph will be of this sort. 4 minus x square, you draw minus x square like this, and then you, for 4 you move 4 units up on this axis, so it will be this kind of a graph. And then you need to take the maximum value, so just take the value which is above, so this will be the maximum. And then you will ask to find the minimum value of this function, and the minimum value can either be this or can be this. So you can just equate them and get the answer. So, and you'll get it. I've just made this, so the question might not be as straightforward, but in the exam it will be easy to do. So just get that. What Ram, the books, what they suggest is a slightly more convoluted, where you're trying to get around the graph. What they'll say is that whenever this kind of a question comes, just equate, and whichever value comes, just substitute and check. But it's not that straightforward. I could have just asked max value here in place of min. And if I had asked max value, you would have been caught short, because max value here is infinity. The graph keeps going till infinity, right? It keeps increasing till infinity. So the maximum value is infinity. By equating, you won't get the maximum value. So that's why I would recommend that you understand this thing and then go and solve this, because otherwise you will be taking a lot of risks, and you still have 8-9 months. So there is enough time to get good at this stuff. If it were like 1 month into the exam, I would have suggested maybe you try some roundabout methods, but this is the most sure shot method, and it's not very difficult once you have become used to the right methodology. Now we'll change gears a bit. We have talked a lot about graphs. It has been 1 hour, I can see. We'll try and wrap up in the next 15-20 minutes, hopefully. We'll do some questions on absolute values, just so that some of them are easy, some of them are not so easy. And we'll try and cover fractional values and greatest integer function as well. So here you can see solve mod 2x minus 5 is equal to 9. Straightforward question. A lot of us have done. I'll just cover it once for completion's sake. So this can be solved because 2x minus 5 equal to 9 and 2x minus 5 equal to minus 9. And why can we write it like this? This is because absolute value. So if it were minus 9 or 9, the function would have returned the absolute value, which would have been 9. So you can always break these kind of equations in this manner. And then you solve both sides. And this side is equal to minus 9 plus 5 minus 4 by 2 minus 2. So this is a common way to solve such questions. It could have been anything, x plus 3 equal to 2, and then you will again break it down into x plus 3 equal to 2, and x plus 3 equal to minus 2, and then solve. So this is just to solve the very basic questions. Now, I think it was discussed in the group earlier as well, and I'll just cover it again. So if a question is of this sort, x plus 6 equal to 2x minus 3, now it becomes a bit more trickier. Because if you break it down, and this is only true if 2x minus 3 is greater than less than 0, and this is true if 2x minus 3 is greater than 0, and then you'll need to break it down again. X plus 6 equal to 2x, because each time you are removing the mod function, you have to take that into consideration. Sorry, I'll write it here. This will be if x plus 6 greater than 0 and 2x minus 3 greater than 0. So it becomes a bit messy. You can solve it this way also, but and then you'll have another option, which is minus x plus 6 equal to 2x plus 3. And same way, you'll need to break this one also into two parts. So you'll get 4 set of equations. 2 of them you can combine, but then again there will be various conditions. It becomes much more complicated. And so there is an easier method, but you need to be very careful. In this case, let me just remove all this. You can also square both sides. So you can just square both sides and solve that, and that would be the same as solving this. And that is because there is a mod function on both sides. If it were not on both sides, if it were not sure that this works for both these sides will always be positive, you cannot square. So remember that condition. Right now you can squaring both sides, but if the mod function were not there on either side, or if it were not for sure that both sides will always be positive, you cannot do this. But here you can, and then you will get 4x square plus 9 minus 12x, and then you can just solve that. 3x square minus 24x minus 27 equal to 0, and x square minus 8x minus equal to 0, and this will be x minus 1 and x plus 1, and so you get the values x equal to minus 1 and 9. So you can solve very quickly this way. So just ensure you know where you can do this and where you cannot. You cannot do it always. So just bear that in mind. Find the range of x if 1 by mod x minus 2 is less than 5. I think I can do this. This will be method of intervals actually. So I'll just introduce this a bit. So this can again be written as 1 by x minus 2 less than 0.5 if x greater at 1 by minus x minus 2 less than 0.5. This is x less than 0. Sorry. Greater than 0 and x less than 0. And then you just need to solve it. 0, 1 by 2, I'll take 1 by x minus 2 to the other side. Subtracting, you will get x minus 2, x minus 4. And then you can plot it on an axis 0, 2, 4, plus, minus, plus, minus. So the values that are acceptable are 0 to 2 and 4 to infinity. And because you need to take only greater than 0 values. And same way, I'll do this one also. 1 by 2 x minus 2 x plus 2, sorry, x plus 2 and x plus 4. Sorry, I made a mistake here. 0 will not be here. Sign wouldn't change at 0. So it will remain plus although, but we'll cut it at 0 because 0 is not part of the, less than 0 is not part of the domain. And same way here. And since we want greater than 0, here the answer will be minus infinity to minus 4, union minus 2 to 0. You can put equal to sign either way. You can put equal to sign here and then include 0 also. And then you need to combine both solutions, on which you will get minus infinity to minus 4, union minus 2 to 2, union 4 to infinity. This plus minus plus, how I did this particular part is how you solve polynomial inequalities by method of intervals. I think some of you know this. If you don't, please find out how to do this. It's very important. This is the way it is done. I'll just give a very quick overview. Is if you had to find how, for what value this will be greater than 0, we'll just plot it on the number lines. We put all of these equal to 0 and plot them on the number line. And then start putting plus sign from the right hand most and just do plus minus plus. And wherever there is a plus, the function is positive. So in which case this will be minus infinity to 1, union 3 to 4, union 9 to infinity. And there are conditions on this. X coefficient should be positive. There should be 0 on their side. But otherwise, and all numbers which are definitely positive should be removed. For example, if here were x square, we would have ignored this. We wouldn't have put x equal to 0 as a solution. So this is method of intervals. You should read about it, find out about it. There is videos on the portal as well on this and questions. So read them, read about it over there. This is our final part for today's session. I think I have covered a lot, although a lot of it was basic stuff. So greatest integer function. What is the greatest integer function? It will just give you the greatest integer that is below that number. For example, for 2.3, it will return 2. For 1.5, it will return 1. For 0.6, 0. And for minus 2.3, it won't return minus 2, it will return minus 3 actually. There's a mistake. Minus 3. Because it will return the greatest integer below that number. Minus 2 is above minus 2.3. So it won't return minus 2, it will return minus 3. Minus 4.6, it will return minus 5. And the graph of the function is of this sort. So for any number between 0 and 1, it returns 0. For 0 also it returns 0. That's why this is a full circle over there. For 1, it will return 1. So there is a hollow circle at the bottom indicating that for 1, it doesn't take this value. And there is full. So this is the kind of graph that we have for greatest integer function. Questions are asked on this, and that's why we are covering it. There's also another concept which is not that, but it's fractional part of x, which is a function which just returns the fractional part. So for 2.3, it returns 0.3. For 3, it returns 0. For minus 1.7, it returns 0.3, which is whatever is the fractional part of that. And it can also be defined as x minus greatest integer function of x. Whenever you see a question of fractional part, it makes sense to write it this way. Many a times the questions get solved when you break it down into this way. So x is the part of integer part and the fractional part. In case you want to see the graph, not very important, but the graph will be of this sort. For 0, there is no fractional part. As then it gets closer to 1, the fractional part increases. And then as soon as you reach 1, again, there is no fractional part. So this is the nature of graph of the fractional part of x. So let's just solve one question on this. There are more on the portal, so you can do more over there. This is again previous cat question. Find the value for which cat x mod x is equal to 40. X, greatest integer of x, is equal to 40. So the way you need to get some feel of this function, right? So if x is equal to 6, then greatest integer of x will be equal to 6. And so x greatest integer of 6 equal to 36. If x is equal to 7, greatest integer of x is also equal to 7. and x equal to 49. Hence, the number will be something between 6 and 7. It will be a 6.xx kind of a number, for which the greatest integer function will be 6, right? So now we can write this as 6x is equal to 40, and then get x is equal to 40 by 6. Again, fairly conceptual question. You know the concepts, you understand the function well, you should be able to do it in hardly 45 seconds. Kim is asking, fractional part is always positive. Yes, fractional part is always positive, Kim. And you can check that for negative numbers. Minus 2.3, you will remove minus 3 from that and say that the fractional part is 0.7. You would not say the fractional part is 0.3. So that is true. So this is there. I am tempted to stop here. This is what I had thought of covering. I went through it reasonably quickly, but it's all there on video, so you can always pause and revise and write. And that's the better way to go about it, rather than me spoon feeding each and every part of it, because then you will be putting pen to paper, trying to understand stuff, and that will help your development. So let me know if you want something else to be covered. Let me know if you thought it wasn't very a very useful experience, because then we would try and revisit the format if we want to do it something differently, or if you want to go about it in a different manner. The purpose here was just to ensure that you get some conceptual flavor. All of this stuff is available in the videos. The questions are also available. So that I not doubt you can do it yourself also. You don't need to attend these sessions. But the idea was just to show ki, one was ki some of your concepts become clearer. The other was that you also see how you need to approach the question, how quickly your hands need to move, how time is very critical and you need to solve it fast. You cannot sit and think about questions, and that's why you need to be very on top of each and every question you have done. When you have done it, you should know कि कैसे होता है. I just know each and every question, each and every graph, each and every formula, everything is very well laid out in my head, so that when question comes in the exam, I can very quickly go through whatever tricks I have learned throughout my, or whatever fundamentals I've learned throughout my preparation. So I would stop at this. I would wait right now for 2-3 minutes, just in case you have some questions. And then we will close this session. Came more difficult questions. It's very difficult to decide which audience you are targeting, and that's why I don't know what to do. If I choose very difficult questions, it might be that there are 2 people. Right now there are 9 people, so there might be just 2 people attending the session, in which case you do not know whether it's worthwhile. If you go very basic, then it gets too boring. Most people are not interested. I tried to create a balance, probably slightly more towards the basic stuff, even though I was trying to keep it at advanced level. So I can always put in more difficult questions, but I think the audience which is there for more difficult question is able to solve most things on its own. It doesn't need a live lecture to be doing more difficult questions. It's able to look at the questions, find the solution, understand, and do it. Sure, Ram. So now there are 2 people out here who are asking for more difficult questions. So we'll have a session on more difficult questions themselves, and do some of the tougher ones. A lot of these were actual CAT questions, but I get it. I get your point. There are more difficult ones also which have been asked, so I can pick them up. So that's one good one. Let us. We might be. I'm not sure, but in the pro side, we might add a few more people, just because I think the number of people we have is slightly less for creating groups, because if we have like 10-12 people who are very interested in tough questions, it's much more easier to organize those sessions for difficult questions. So let's see how it happens. So it might be like in 1 or 2 days or 3 days, within 1 or 2 weeks or 3 weeks, we have those kind of sessions. Anything else? Okay, it seems only 2 people are listening. Rest have just switched on the video and left because I had asked them to attend. Okay, thanks. Kim, thanks Ram. The video will be available on this website. I'll see if I want to put this video also on our portal, because we are covering some of the material over there. So it might be useful for people in the future as well. Thanks a lot for attending, and thank you.